So how are we going to deal with everybody's favorite piecewise functions? Well, that's where this gets interesting. And piecewise functions are liable to have a jump discontinuity because if you remember how you get a piecewise function, um, this first part of the function exists before x equals 1. So it's a line. It's not going to look exactly like this. We can be careful with graphing it, but let's just say it's a line. It stops at 1, but it can equal 1 right here, so there's an open circle. And then after 1, this parabola takes over. So you have some kind of U shape like that. Now, I haven't really looked at what these graphs look like. You could really graph this pretty easily if you wanted to, but point is this. If the graph did look like this, there would definitely be a jump discontinuity, non-removable. However, if the graph actually looked like this, say this function took over exactly where that function left off, then you would see there's no discontinuity at all. So we have to figure out what's going on for this piecewise function at x equals 1. And since we've talked about one-sided limits, we'll do it in terms of one-sided limits. Basically what we're going to do is, let me get this back up, is we're going to find the limit of this function as x approaches 1 from the left. Then we're also going to find the limit of this function as x approaches 1 from the right. And if they match, no discontinuity. If they don't match, we have a jump. So that's basically it. So here we go. This function, if you take the limit as x approaches 1 left, since you're on the left side of the function, since you're on the left side of 1, we need to use this part of the function. So wait, let me start over again. I shouldn't have done that. That's how I wanted to write it. You would be using this part of the function. So this would be 2 times 1 minus 6, which equals negative 4. Then we have to figure out what happens from the right side of 1 of this function. And that would be, this is the bottom function is the one that exists in the right part of 1. So that would be 1 squared minus 3, which is negative 2. These don't match. Therefore, we have a jump. Discontinuity at x equals 1. Graphically, we can now think of this graph better. This 2x minus 6 part is a line, and we've just figured out at 1, it reaches negative 4. So here's 1, here's negative 4. Closed circle because of the or equals to. Then we have this parabola that takes over at 1. It's at negative 2. So we're here, open circle, finish out the parabola. That's probably a pretty good idea of what that piecewise function looks like. So for those of you thinking you're taking the AP exam, all this notation is really, really important. So I wanted to show you that way first. The quicker way to do this is this. I mean, if you can think about why this works, but just plug 1 in. See that 1? Just plug it into both. If they match, it's continuous. If they don't, it's not continuous. But I want you to get used to proving it with one-sided limits, so that's why I'm showing it this way. Let's look at the next one. The next one is very similar to the first one. But now this one is, the questionable point would be 0, because that's where the first function stops and the second function takes over. So I'm going to figure out what the limit to the left side of 0 is. And then I'm going to determine what the limit on the right side of 0 is. I see I messed that up. I will fix that. I said left side of 0. So let's fix this. Now, when you're taking the limit of this function on the left of 0, this is the function that's to the left of 0. So this would be 2 times 0 minus 6. Minus 6. Which equals negative 6. When you find the limit of this function as you approach 0 from the right, you're using this. 0 squared minus 6, which equals negative 6. They match, which means this function graphically hits 0, would stop at negative 6. It does equal it, so it goes circle. This function takes over exactly at negative 6. So I would draw an open circle here, and then that parabola. But that open circle and closed circle together make a closed circle. This function is continuous everywhere. So I would say continuous on the interval negative infinity to positive infinity. Next question. Now this one's going to be a little bit different, so keep watching. So I'm going to do the same thing though. But now the point in question is going to be 3, because that's where the first one stops and the other one takes over. So I'm going to do the same thing. I'm going to do the same thing that I've been doing. Find the limit of this function as x approaches 3 from the left, and then find the limit of this function as x approaches 3 from the right. And then determine if there's a discontinuity or not. So when you approach 3 from the left, you're going to get negative 3 plus 2, which is negative 1. When you approach 3 from the right, you're going to get oops, I messed up. I'm sorry. Glad you caught that. Thank you. When you approach 3 from the left, you get positive 3 plus 2, which is 5. Sorry about that one. When you approach 3 from the right, you get 3 times 3 minus 4, which is 5. Okay, so now let's make this an AP question. On the AP exam, they're going to want you to actually use the definition of limit, the definition of continuity to figure out if it's continuous, which includes all the limits. So even though this may look like it's continuous because they match, that's not all that has to happen. So I'm going to go back here. For a function to be continuous at a point, these three things have to be true. F of c must be defined, the limit has to exist, and those two things have to match. We already know the limit exists because the limit from the left and the right are the same. However, f of 3 would have to be defined if this is continuous at 3. So if you try to figure out what is f of 3, well, you can see none of these equals 3. This function never equals 3. The first part's less than 3, the second part is greater than 3. So this is actually undefined. So you're going to have to say this is not continuous at 3. I wanted to show you that way because that's what you're going to have to do to actually really justify your answers in an AP exam. But the easier way to do this, if you didn't really have to justify, is just notice that they don't equal 3. So even though these match, they'll both match with an open circle, which means we're going to have a removable discontinuity. So if you wanted to think about what the graph looked like, here's another way to look at it. This x plus 2 function equals 5 at 3. With an open circle because there's no equal sign. This 3x minus 4 function is also 5 there, but with an open circle. So you can see that's a removable discontinuity at x equals. I hope that made sense. If you need to watch this again, watch it again. If you do have questions after watching this, please ask. So that's all. That's continuity for you. There's another question that we may go over, and then these types of questions that we'll go over probably live. So that's enough for you to digest for now.